Assalamualaikum warahmatullahi wabarakatuh. My name is Syahirah binti Muhammad Samri. Okay, in this presentation, I will explain more detail about my final project, which is the development of a solar power portable bridge for river site. Okay, first I will start with the introduction of this project. Okay, the demand of the bridge are in the increase for the businesses, especially in the industry like mining, quarries, iron estate, and also powder industry that involve bulk movement. Okay, this is because weight is give high accuracy and efficiency in measuring the weight of load, and it is also to avoid the vehicles vehicle from exceed the maximum permissible weight established in the registration of road transport of goods. A truck scale can also be installed at the ground level, above ground, or in ground with all kinds of sizes. In Malaysia, many projects have utilized solar energy as the renewable energy resources for the replacement of the other resources to produce electricity. Okay, next for the progress statement of this project. Okay, as we know in the Liverpool side, the installation of the weight bridge has been the issues as the electricity supply is one of the problem that need to be faced. Okay, about 15% of the quarries will operate with a single weight bridge, so any breakdown of the system can stop the one side from operating. Okay, almost most of the existing racing machines can measure the heavy load truck, but they still cannot produce an accurate data output and do not provide with a backup power supply. Okay, due to these issues, this project come out with a portable bridge that powered by solar system. Okay, for the objective, there are three objectives that have been set up for this project, which are the first one is to design an Arduino microcontroller based on legacy machine using a cell. And then the second one is to investigate the application of PV as a power supply for the legacy system. And then the last one is to develop a prototype system of weight bridge by integration of hardware and also software. Okay, that's all for the scope of this project. Okay, the first one is for the weight test. Weight scale will be mounted with different number of load cells, which one load cell, two load cells, and also four load cells to measure the different weight of loads ranging from 0 to 40 kg. Okay, next, PV panel will be installed to generate the power source and as a backup energy for the system. Okay, next, this project also is designed by interfacing of load cell and HS711 weight sensor with the Arduino Uno R3. Okay, the last one is the schematic of the hardware part of the system will be modeled by using Project and also Arduino IDE software. Okay, next for the methodology of this project. Okay, as we can see here, this is the wall connection of this project. Okay, first the solar panel will supply the electric to the system. And then this solar charge controller will limit the water from the solar cell from overcharge the battery. And then when the battery supply the electric power, the solar cell will detect the weight and then it will transmit the mechanical weight output signal to the HX711 module. Okay, this HX711 module is a 24-bit ADC, which it will amplify and then send the load cell output to the Arduino. Okay, and then lastly, the Arduino will calculate the output of the HX711 and then it will convert it into the weight values and finally will display it to the LCD display. Okay, for the flow of the solar powered battery system, first the system will be powered up by the solar energy, or if the system does not receive any solar energy, then the battery will be used as a backup to power the system. Okay, this project is divided into two parts, which the first one is the calibration test, and then the second part is weight tested using truck scale. Okay, for the calibration test, three different types of tests, which is centricity test, repeatability test, and also historicity test will perform on separate or combined load cell platform that mounted using one load cell of 10 kg, two load cells, and also four load cells. Okay, then for the weighting phase, the testing measurement was performed based on the result from the calibration test that are the most accurate weighing method. Okay, in this experiment, two different sizes of touch scale, which is a large touch scale and also small touch scale, were used. Okay, the weight of the load then will be displayed on the LCD. However, if the weight of the loads that put on the weight scale are exceed the limit of 40 kg, the value of the weight will not be displayed on the LCD. Okay, next I will explain for the result that have been obtained from the experiment that have been carried out. Okay, first for the simulation part, the simulation of the weighing system with one load cell have been done in the Proteus software. Okay, this is the schematic sketch of the weighing system using one load cell. Okay, as we can see here, this is the load cell. It is connected to the HX711 module. Okay, this HX711 then connected to the Arduino Uno R3. Okay, last one for the 20x4 I2C LCD is also connected to the Arduino Uno R3. Okay, the code has been written in the Arduino IDE software. Okay, from the code, the HEXY is loaded onto the Arduino Uno R3. Okay, then I will run the system. Okay, when the LCD shows the total weight, then we can enter the load weight that we wanted to be measured over the load cell. Okay, for example, we enter 1, which is we assume as 100 gram of load, and then the total weight will be displayed as 100 gram. Okay, then if I enter 2, then the total weight will also be displayed 200 gram. Okay, from this simulation, it can be proved that the system was accurate as the output of the weight that displayed on the LCD are same, which are the applied weight at the load cell. Okay, next for the hardware part, the calibration tests have been carried out first. Okay, the calibration tests have been performed in 3 different types of tests. It is intensity test, repeatability test, and hysteresis test using different type of load cell platform. Okay, as we can see here, it is the weighing system using one load cell, and then it is weighing system using two load cell, which is separately mounted in each of the platform. And then it is using full load cell that also separately mounted in each of four platform. Next, it is the weighing system using two load cell but combined together on one platform. And the last one is using four load cell that also combined together on one platform. Okay, first the eccentricity test. Okay, as you can see from the data that have been obtained, it shows that the round platform using one load cell is the most accurate as all the output weight in every position were 100 gram. However, for the testing on the square platform shows that they still achieve the accuracy at position 1, which is at the center of the platform. Okay, for the second test, it is the hysteresis test. Okay, the data of the hysteresis test are represented into the line graph of the loading and the unloading weight, ranging from 100 gram to 400 gram with the 100 gram increment or decrement at a time that are measured on all types of the load cell platform. Okay, as you can see from the result, it can be concluded that the system is more accurate when using one load cell, two load cell, and four load cell that separately mounted on the platform with less different error of about 0.2 gram compared when using the load cell with the combined mounted method. Okay, the average value for the weight of the load was determined by taking repeatedly for 10 times for the output of the 400 gram weight. Okay, from the data, the output weight average reading can be calculated to find out the different errors and compare it with the input weight. Okay, as you can see here, the figure shows the error that have been calculated based on the result of the 400 gram load used that have been obtained for each of the different load cell mounted method. Okay, the highest repeatability errors with 0.14 gram was the test when using 4 load cells that are combined together on one platform. Then the lowest error among all was the test when using 4 load cells that mounted separately on each of the 4 platforms. Okay, the second experiment is the load weight test. Okay, based on the result of all 3 calibration tests, the method of 4 load cell that separately mounted was used in this load weight test as it was the most accurate method among the other methods that have been tested. Okay, the experiment test was performed using 2 different sizes of touch scale, which the first one is one large touch scale with 183 gram, and the second one is the small touch scale with 65 gram. Okay, the weight test data was taken repeatedly for 100 times to get an accurate data. Okay, as you can see, the figure shows the average reading that have been obtained during the experiment for two different sides of the toy truck. Okay, the aim of using these different sides of the truck scale was to identify the performance of the load cell platform, whether the load cell will produce an accurate result or not. Okay, based on the bar chart, the difference of the average reading of the large truck scale from its actual reading was small, which about 0.2 gram when using 100 gram of weight load, and then 0.58 gram when using 600 gram of weight load. Okay, in addition, the tested using the small truck also giving the same result with the different gap with its actual weight were small. As for the minimum load test, the difference was 0.39 gram and 0.61 gram for the maximum load test. Okay, what I can conclude is from this both track scale test, it proved that by using this weighting scale of one laser that's separately mounted in each of the platform, the result obtained are accurate with less different error from the actual weight. Okay, as a conclusion from the experiment, the performance of the weight system of four load cells that mounted separately that tested using the small touch scale and also large touch scale with 100 gram and 600 gram of loads prove that this weight system is accurate with about 99% with only small difference of error from the actual weight. Okay, however, the different error of the weight can be further reduced by adjusting the calibration factor, or maybe it is caused by the environment factor. Okay, in real application, this weight scale using four laser that mounted separately can be developed into the portable weight bridge of four separate platform, which each of the platform will linking each of the truss tire and powered with the solar system. Okay, that's all from me. Thank you.